Can one £400 electric radiator actually heat a house built to super insulation standards and in the process save you more than 10 grand on a massive overcomplicated heat pump? And here's the bigger question: can we use this approach to scale to your average 90 to 100 square metre 3 to 4 bed house? Well, let's find out. I built this micro home to answer some of these eco questions, and this isn't some garden room or extension. It's a fully functioning small home with drainage, water, electric, full planning and building regulations approval. And if you want to talk about your own project and get a little bit of help, you can click on the link below to speak to me. This is my live test tube to put the claims under the microscope in real time. And for this build, I wanted to achieve a building envelope, that's our walls, floor and roof makeups, an envelope so good that heat transfers through so slowly that almost no heating would ever be required, even in winter. Think of it as a bigger thermos flask with integrated ventilation. And we measure the speed that thermal energy transfers through the walls in U values. Now my walls hit 0.5 U value, nearly twice as good as the average of most standard UK new builds at around 0.28. If my wall is 0.15, heat crawls out so slowly the human body alone can almost keep up and replace the thermal transfer. But by incorporating my reflective airtight vapour barrier on the warm side, this drops it further still to 0.14, bouncing the inside heat back like a mirror, just like a flash does, and therefore it saves even more on the bills. And it does the opposite in summer when we want it to stay cool inside as the sun is beating down on that roof. And talking of roofs, I'm building a warm roof, and that's insulation over the joists, not between, and even lower than our walls at 0.12, since the majority of our thermal transfer naturally tends to want to transfer upwards. And if you want to see the right way to build a roof like this and why to avoid the standard solution being built, check out the video here. So down to our floor, and I'm achieving 0.15. That's this much closed cell within a suspended timber floor with a minimum 150mm ventilated solum on the cold side. And don't scrimp on that solum space whatever you do. And if we want to make that a warm floor, we'll add a layer of PIR on the cold side if we've got the space to insert it. Now my warm wall system is less than half the insulation thickness of these other eco solutions such as cellulose, this much less than SIPs for the same U value, and with way less cost and engineering requirements. It still smashes U values past current regulations. I've deployed it in new builds, extensions, full renovations, every time with a fraction of the hassle. My aim is to help you and homeowners take control of this process and get the architects and builders to help, but you control the specifics, it's your money. And if you're interested in learning about this exact building system in detail, I'll leave a link below. Now here's where the magic starts. Whereas a 25 square metre house built within the past years needs this much kilowatt hours of energy within its envelope if we were using the standard, the U values required, this house only needs this much kilowatt hours of energy all year for all its heating and its hot water. That's 65% less energy without us doing anything. And how do we know that? Well, by using our U values and this guidance. It's actually a simple formula, and with our fabric total at 27 kilowatt hours per metre squared, and you can pause the screen here to see where that comes from, and our ventilation along with our airtight layer, we get 43 kilowatt hours per year, and 25 square metres times 43 gives us our annual electricity, and this is why we're able to use just one electric radiator. Here's the maths on the optimal size of the radiator if you're interested. Now we're going to use one Ecostrad Addesso £430 radiator, 1.2 kilowatts, slim, oil-filled, Wi-Fi controlled, a straightforward 2-hour install. Now there's a load of oil-filled radiators out there that will do the job we want, but I treat radiators, their valves and their placement as if they're pieces of furniture, and you should too. You'll be looking at them forevermore and you're sitting in your living room, so don't scrimp. I think this Addesso is really well proportioned. It doesn't stick out too far like some of the competitors, and I like the box look of it. like several vertical planks that match the design language I'm creating elsewhere within this micro home. Take that language from outside to in, take the occupants on that journey, all these small decisions that are part of a bigger whole picture, they all link together to create that memorable experience that enlightens us and inspires us in our daily living when we have great architecture, which I hope you're able to do as well. Now, I approached Ecostrad and asked them if they'd be interested in me using their product for this video. I was going to buy this model anyway for the project, but they offered it for free, just for full disclosure. I'll give my detailed thoughts on the Ecostrad and the Addesso range in a separate video I'll post below. Suffice to say, it's an impressive piece of kit with a few things to bear in mind. And we then need to consider our hot water. About 650 kilowatt hours annually from one direct mains hot water cylinder, and that translates to an annual energy bill of £546 a year before any tariff reductions such as off-peak storage. I'll use this direct off the main cylinder, costing about this much, plus about a few £100 in pipe work. And although I did all this install myself, I waited for my heating colleague to ensure that all the pressure is protected with the relief valves working properly. Now, ventilation. I'm skipping an MVHR and all that expensive ductwork. An MVHR system is a whole house ventilation system that pulls any heat from the air and recycles it before it extracts the stale air. And instead I'll choose this EnviroVent Silent MV. It's a few £100, much more expensive than your average fan, but still cheap compared to MVHR. And by adding a couple of sensors, we can make it humidity triggered and several decibels quieter than your average inline fan. Still using ducting with this inlet for the controlled entry, but way less ducts and vents than MVHR. We're cutting a couple of 110mm holes in the timber frame, foaming and taping around the outlet ducts and fitting in line in the suspended ceiling void. A day's work and we're pretty much done. Fresh air and controlled air changes within our airtight envelope work perfectly. In a 25 square metre microhome, one is plenty, but what about losing out on the heat recovery I mentioned that the MVHR includes? That adds about £40 per year in lost warmth, a tiny amount in my view, but saves thousands in upfront costs. So our total cost for our 3 bits of kit, radiator, hot water cylinder, silent fan and duct to the outside, is £1,300. Probably another £500 or £600 if you wanted to get someone to complete the pipe work yourself, but I'm sure you can do it. Now, our U values, an envelope flask does 90% of the work. There's no government grant for this, but there's no commission, there's no 10-week wait, and there's no gravy train of middlemen and bureaucrats. Now let's compare that with the alternative, going down the route of a heat pump with hot water heating and the heat recovery thing, MVHR. The heat pump we might consider for a smaller home is this Mitsubishi Ecodan. I think it's 4 kilowatts. It's an indoor unit with a pre-plumbed hot water cylinder included, no underfloor pipes, warm air ducts using 2 or 3 high temperature fan coil units that you'd set within a wall or ceiling void, slim cassettes pushing warm air around 40 or 50 degrees I think. This has a COP of 4.5, and COP 4.5 is more jargon they love to confuse us with. It basically means for every 1 kilowatt hour of electricity the heat pump uses, it actually pulls in or creates 3.5 kilowatt hours of free heat from the outside air. So our 1,750 kilowatt hour demand that we worked out earlier becomes 389 kilowatt hours of electricity and reduces our bill. In comparison, our electric radiator has a COP of 1.0, 1 kilowatt hour in and 1 kilowatt hour heat out. Still way more efficient than gas, but not nearly as efficient as the heat pump. But you want the government grant, right? Then there is no DIY, no self-build, no making your own decisions in your own time. You must use an MCS certified installer. Now, the MCS installer will likely recommend MVHR to maximise that heat pump efficiency. After all, why spend 10 to 20,000 on a heat pump and then lose heat through ventilation? So you add a proper small MVHR to the micro home. That's about this much for the unit, install and ductwork. So let's look at the real real 15-year costs for our microhome electric system versus our heat pump with MVHR. The electric system up front, here's the running cost. The 15-year total comes to this in the heat pump and MVHR. With the grant, which is for the heat pump only, it's this much up front. The running costs of this and the 15-year total is this. So yes, with the grant, the heat pump route wins on paper over 15 years, but only if you're happy to pay £4,500 to £5,000 up front instead of the £1,300. Wait several weeks, if not months, for MCS sign-off and install a £12,000 machine plus ducting to heat a 25 metre square box that one £350 radiator sorts out. For me, still way overkill. I'll take the simple £1,300 route every time, and instead I'd use the money saved on the heat pump evangelism by installing solar and eliminating the energy bill completely. For a 25 metre squared microhome, the electric radiator wins on simplicity and upfront cost, even if the heat pump edges ahead over 15 years with the grant. But here's what you really want to know, right? Does this scale to a normal house? Not many of you will be building microhomes, so let's scale the technology we used for the microhome up to a 90 to 100 metre squared house. Your average modern 3-bed built to the same super-insulated standard, and now the heat pump crowd will scream, you need MVHR, you need heat recovery. But do you though? MVHR costs £8,000 for a house like this, and that's the unit, all the ductwork, labour and builder's work for sealing voids and penetrations. It saves you about £150 a year in heat loss from ventilation, and the payback is this many years. It's crazy. In a super insulated house where heating is already cheap, why would you spend that much to recover heat you barely need? Here's the truth. MVHR only makes sense when your heating system is expensive to run, like when you've already dropped £17,000 to £20,000 on a heat pump installation. Then you're desperate to claw back every watt. But with electric radiators, a simple extract strategy like I used in the microhome, simple, cheap, and in a 90 square metre house with the same envelope quality, here's what you'll actually need for the electric system. 3 radiators strategically placed throughout the home, hot water cylinder and pipe work, and extract fans for the bathroom and kitchen, humidity controlled with space allowed to circulate throughout the whole house. And the total upfront cost is going to be this. You can further make that more efficient with zoning via apps. Your total running cost is going to be around £1,700. Your 15-year total is this much. Now compare that to the proper heat pump system, and the combined upfront cost is £25,000. Let that sink in. Heat pump and MVHR with the £7,500 grant is £23,000 over 15 years, and now the heat pump wins by about £4,000 to £5,000 over 15 years. But here's what that really means. You'll pay £17,500 up front versus £2,400 for electrics. That's £15,000 of cash out of your pocket on day one that you can't use for things like solar or electric vehicles and all sorts of other money-saving stuff, to save £4,700 over 15 years. And that's still assuming there's no maintenance on the heat pump, no repairs to the MVHR motors or filters. The system lasts the full 15 years, and in reality you're looking at 15 years plus before you're actually ahead, if you ever are, given we're going to be looking at evolving technologies over the coming years. The heat pump lobby say electric heating costs a fortune, and that's why we need heat pumps 4 times as efficient. They forget their solution costs 10 times as much up front. Here's the real truth that no one talks about. None of this matters if your envelope is rubbish. The envelope, the walls, floor and roof solves 90% of your heating problem before you even turn anything on. Build the envelope so good, create that thermos flask we talked about at the start, or renovate to get to that level, and that heating becomes cheap enough that you don't need to recover the heat. And that's the secret the heat pump industry doesn't want you to know. If you want to know more about my warm wall roof floor system, how the condensation protection works, how to integrate services without breaking the airtight layers, and how you can build this to save yourself thousands over other super insulated options. I'll leave a link below. And check out these other videos here for more on how to understand all this stuff.